Let's start. We quickly go through those questions that you might have trouble with, okay? Let's do this one. We do the power rule. Look at this. Olivia, let's try this one. How do we do the power rule?
Okay, so wait, can't we just do, can we move the x to the -3 power up?
Yeah, we do those division first, okay? And then we can simplify. Go ahead, please.
Wait.
This u equals? X?
And then plus x to the 2.
Yes, very good. Divided by this, -2 minus -2 minus -3 is +1, so this is 1. -1 minus -3, so this is +2, correct?
Yeah.
And then we do this guy derivative. What's the derivative?
It would be plus 2x.
1 plus 2x. Nice, that's right. Next one. Angela. Let's do this one. Let's do, hold on. Let's do a derivative for this one. Go ahead.
Okay, can you like put the x on there?
So we change this to the exponential format first. Okay.
3x power -2.
Okay.
Plus 95x.
All right. So.
And then it becomes -1x to the power of -2.
And
then plus 6 times x to the power -3. And then
plus 75. Okay.
And
yeah.
You have to,
that's
like,
it.
No, you have to like put no negative exponents.
Oh, they don't allow you to put a negative. Okay. So we can put this in the denominator. Okay. Yeah.
And then plus 6 over x cubed.
And plus 75. So far, so good?
Yeah.
Yeah, I don't see. Let's also try this one. Look at this. If we have this kind of question, how do we do the power rule? Let me call the next student. Emily. Let's try this one. Okay. If we want to. Yeah.
Okay. So you put the square root format into an exponential format.
Sure.
So it'd be -1 divided by x to the power of 3/2.
A -3/2. Makes sense?
Yeah.
Because on the denominator. Plus?
Yeah, plus 1 divided by x over that's just 1. Yeah.
Hold on. This guy is same as x to the power of -1/2, correct?
Yeah.
Okay. Now let's do the derivative. Go ahead.
3x to the power of -5/2.
Hey, hold on. We want to times this, correct? We want to times this in the front, yes?
Oh, yeah.
And then x to the power of this guy -1, right?
Yes.
-5/2. And then plus 1/2 times -1/2. And then x to the power of how much?
-3/2.
-3/2. If we want to further write this without the negative exponent, what do we do?
1 over x to the power 5 over 2, which is 1 over 5 times the square root of x.
X to the power of 5, yeah.
Oh, yeah, that's what I meant.
Yeah, and we can also take the x out, yeah.
Yeah.
We can take the x out. Why? Because look at here. X is under the square root. That means x is bigger than 0. So we can safely take x squared out, correct?
Mhm.
Yeah, we can take x squared out and leave a square root of x. And then minus 1 over 4 times
1
Times one.
over square root of x to the third.
Right, so x can take it out. We
Yeah.
have a square root x. All right, yeah, I think the students here are pretty good for this kind of question. Now, let me do this. We are going to do those product rule, okay? We have to be very familiar with the product rule. Olivia, look at this. How do we get this guy? What's this guy?
It would be the derivative of of f of x times g of x,
Yes,
and then plus f of x times the derivative of g of x.
there you go. Very good. Oh, sorry. Now let's see. This guy. Go ahead, Olivia.
Okay, so 3x squared times cosine x, and then plus x cubed. Oh wait, actually, and then times negative sine of x.
Minus.
Minus 2 cosine x.
Yeah, perfect answer. Very good. All right, that's it. Now, Emily, let's try the quotient rule. Do you remember the quotient rule?
Yeah, it's g of x times the derivative of f of x minus f of x times the derivative of g of x divided by g of x squared.
Oh, perfect. So we will do d of fx times gx copy down minus d of gx and fx copy down. Okay.
Mhm.
Now let's do this example. Go ahead.
So it's cosine x times the square root of x cubed minus sine x times 3x squared divided by x to the 6th.
So this guy is on the denominator. Sine x derivative is cosine. This guy copy down. And then minus sine x copy down. X cubed derivative. That's it. Correct?
Yes.
Yeah, so far very good. Angela, try this one, please.
Okay. I think student can use the quotient rule.
Okay.
So then first it's going to be 2x times x to the power of 1/4.
So this guy is 2x times.
X to the power of 1/4.
Okay.
Oh, is it power to negative 1/4?
No.
No.
No. No. Look.
Oh, wait, no, right. Yeah.
Okay.
Yeah. No, I get it. Okay.
Yeah.
And then minus,
Every student, pay attention to here. Don't confuse yourself. Don't put negative. When you do this guy derivative times this guy copy down minus this guy copy down, this guy derivative. Okay, don't confuse yourself. Minus
Okay, minus x squared plus 2 times 1/4 x to the power of negative 3 over 4.
Oh, this guy is 1/4 x to the power of
Negative 3 over 4.
3 over 4.
And then at the bottom is x to the power of 1/2.
X to the power of 1/2. Okay. Now, if your teacher don't allow you to do this, you can write down one more step. Okay.
Okay.
All right. Now, Emily, I want you to tell me all these formulas. Go ahead.
The derivative of tangent x is secant square x. For cotangent, it's negative cosecant square x. Secant x derivative is secant x times the tangent x, and then the derivative of cosecant x is equal to negative cosecant x times cotangent x.
Yeah, all of you do so well. Well, you remember all of them, but I want to see if you can derive this, okay? Because when they test you, if you know how this come from, even though you forget, you still can get it. I'm going to call students. All right. Aiden. Aiden, can you hear me?
Oh, yeah.
Y equals to tangent x. We know that sine x derivative is who?
Oh, sine x derivative is cosine x.
Tangent x equals to who?
Sine x over cosine x.
Okay. I want you to do the quotient rule. Go ahead.
Okay, it's like cosine x minus sine, derivative of sine x. Cosine x times derivative of sine x.
Hey, hold on. This guy derivative times this guy copy down, okay? Correct?
Oh, yeah, sorry.
Minus
Minus
this guy
negative
copy
sine
down.
x.
This guy
Sine
copy
x.
down.
Yeah.
Times
Negative sine x.
cosine x derivative is negative sine x.
Negative sine x.
All right, so here is negative sine x. Okay. Don't confuse yourself, okay? Divided by who?
Cosine x squared.
Look, everybody here, okay? This guy is same as this guy, okay? But this guy is, you do x squared first, and then you do cosine. So please don't put the two on the wrong position. And everything will mess up. These two are totally different, okay? If, for example, if I have this, what's this guy's derivative using the chain rule?
Wait. Okay. I think it's like 2 times
What's the outlier? This guy's outlier is who? This guy's outlier is using the power rule, right?
oh, yeah.
Right? You put 2, yes? And then
Yeah, times cosine x is
times
the derivative of cosine x, I think.
is what?
It's negative sine x.
Negative sine x. Tell me the double angle formula. This will equals to what?
Oh, that's like sine 2x or negative sine 2x.
Negative sine 2x. Now, Olivia, cosine x squared derivative. How do I do this one?
Wait, is it like
Who is the outer layer? Who is the inner layer?
the cosine is the outer?
Yes.
So it would be negative sine x squared
Yes.
and then times 2x.
There you go. Perfect answer. I like it. See the difference of these two. Your position different. Your answer totally different. Okay, we couldn't mess up here. Okay. All right. Aiden, continue. This top equals to what?
Huh? Oh, it's like 2 cosine x plus 2 sine x.
Hey, hold on. This is cosine square
Sorry,
x.
squared.
So the top is
1.
1 over cosine square x equals who?
Secant squared x.
Thank you. Okay. Next. Cotangent x derivative. Angela, go ahead, do this one.
Okay. Tangent x is cosine x over sine x. So you do negative sine x times sine x.
So you write down this additional step. This equals
negative sine x times sine x.
top one derivative times bottom one copy down minus
The bottom derivative, so it's going to be cosine x times cosine x.
yes.
And then sine squared x at above.
The top one becomes
Negative sine squared x minus cosine squared x.
over
Sine squared x.
equals,
Equals negative cosecant squared x.
there you go. Next, secant x derivative. Secant x is who? Let me call the next student. Emily, who is secant x?
That's secant x times tangent x.
Eh, who is this guy? We want to
1 over cosine.
thank you. And how do we do next step? We can do this guy to the power of what?
-1.
Now, can you use the chain rule, please?
I haven't learned the chain rule yet.
Okay. If you haven't learned the chain rule, I teach you quickly, okay? Chain rule is something like you cut the onion for your mom, okay? You do layer by layer. If you have G of fx, you want to do the G prime first. And then you do f prime. Okay?
Okay.
So what does this mean? This is saying, for example, you have 3x plus 4 to the power of 3, want to do this guy derivative. Well, student, you say, that's easy. I can do the Pascal rule by saying a plus b cubed equals to a cubed. You from the descending order, a squared, a to the power 1, and then b cubed, b squared, and b. And the Pascal triangle is 1, 3, 3, 1, right?
Yeah.
So I can expand this one by using this formula. I'm able to get the derivative, no problem. But what will happen if I give you a 30? Are you able to do this guy with a 30? Yes, but not yes. It's too complicated, it's too long. You don't want to do that way. So the chain rule kicks in. Chain rule is saying, you don't care what's inside here. You do a U sub, okay? Look, you are going to call a U sub. Chain rule is very important. A student, I know this class, most every student are very advanced. If my teaching is too easy, remind me, I will give you a hard question, okay? If you think the question is too easy, text me in the chat. I will make the question harder. Do this derivative, go ahead.
3u to the 3u squared.
All right, so this is the 3u squared. But this guy, the problem is, this guy derivative, your x is your independent variables. But here you change u as the independent variables. So this piece is not equal. There you have to have some additional stuff inside. You have to times u prime. And then this is 3u squared times u prime. U prime is who? U prime is this guy derivative. How much is that?
6x.
Very good. So times 6x. Your original function does not have u. You put u back. Does this make sense now?
Yeah.
Okay. This is called the chain rule. Okay?
Mhm.
So Newton is a guy who defined using prime as a derivative. There is another guy called Leibniz. He defined the derivative as dy over dx. Okay? What is dy over dx? When you do the limit, when your delta x is approach to 0, your fx plus delta x minus fx over dx. Okay?
Mhm.
This is a definition of derivative. That's what Newton called. What Leibniz called dy over dx. When you write down dx rather than delta x, it is saying this guy is approaching to 0. So this guy, when we want to do the composite function, we are going to treat this. The original derivative is dy over dx. But your y is a function of u. So basically you are doing dy over du times du over dx. This is an essential part for the chain rule. This can carry on many, many layers as long as you do your chain rule correctly. Does this make sense to you?
Kind of.
And let's practice. Go ahead, power rule. Go ahead, do this power rule.
So it'd be negative cosine x to the power of negative
Yes.
2.
Yes, very good. Times.
the derivative of cosine x, sine x. Oh, negative
Neg-
sine x, sorry.
This equals sine x over cosine x squared, correct?
Yeah.
And then you make this sine x over cosine x is 10, right? And 1 over cosine x is secant. That's where the formula come from. Make sense now?
Yes.
Yeah, it's very good, even though you haven't learned this, but you already know the formula. That's very good. This is cotangent x. This is secant x. Let's do the cosecant x. Olivia, let's do this one.
Okay. So cosecant x is 1 over sine x.
Okay.
With sine x to the -1 power.
Yes. Equals
Negative sine x to the -2
times
times cosine x. Wait.
times cosine x. Yes.
Okay.
Power rule. First is power rule, -1. This guy to the power of -1 minus 1 times that guy derivative cosine x, right?
Yeah.
Very good.
So then it would be negative cosine over squared x.
Over sine square x, right?
Yes.
Equals
Cotangent x times cosecant x.
this is negative cotangent x times cosecant x. Okay. Yes.
Yeah.
Very good. Yeah. Next. Let's see here. Okay. Yeah. We have some question like this. It looks very confused. We will kick in the product rule. Okay. Angela. Let's do this one.
Okay. So it'll be g prime x times h of x plus h prime x times g of x.
Okay. We are looking for who? When x equals 2, right?
Yeah.
Let's plug in.
Okay, so it's gonna be -4 times -1, and then plus 5 times 3.
This is -1.
No, but I already.
Oh, sorry. I have a typo over here. Sorry, I have a typo. Okay.
So it'll be 5 times 3.
Okay.
And then it'll be
Equals 19.
oh, yeah.
Correct?
Yeah.
Oh, okay. Now, did your teacher teach you EX derivative yet? Aiden, who is this guy's derivative?
just numeric value? I don't know it.
E to the power x derivative is still e to the power x. If we don't know the answer, we will borrow the definition of derivative. How do we write down that? There. Go ahead.
Oh, so yeah, limit as change of x approaches 0. It's I think e of x plus delta x minus e of x over delta x.
Over delta x. Now let's take care of the top one. Can we take this out?
Yeah.
Okay. Okay. Do you know how much is this one? At a certain point, there is something we cannot know yet. So we have to borrow the graphing calculator, okay? So e to the power of x minus 1. I need to do the division first. Yes. So at this position, when it's approached to 1, when it's approached to 0, it is 1. Yes. Limits from the left and the limits from the right is going to approach to 1. So that guy is 1. So this will be e to the power x. Make sense?
Yes.
E to the power x. Okay. So there are some limit we have to remember. Like this. Who is this? Who is this?
Oh, sorry. That's 1.
Yes. Okay, this is 1. So we have to remember this, okay? All right. Now with this, we are going to see a to the power x. Emily. E to the power x derivative is this. A to the power x derivative. How do we do this guy?
The definition.
We already know this result. We might be able to use some exponential properties. Okay, look. A to the power of x can be rewrite as e to the power of ln and then a to the power x. Is everybody okay for this formula? Is everybody okay for here? No? Look. If you say a to the power b equals to a to the power b, correct? Is this always equal?
Yes.
This is always equal. So you can rewrite this as log a a to the power b equals to b. Can you?
Yeah.
Okay. And you can also say log ab equals to log ab. Is this correct?
Yeah.
This is a constant. Yeah, you equals yourself. Okay. So a to the power of log ab u equals to b. Does this make sense? On one side, if you want to move this base to the other side, you put this guy as the base and then equals this. Does this make sense?
Yeah.
Okay. So look at this. If this is true, then here and here, as long as these two guys are the same, this whole thing will just equals to this. Does this make sense?
Mm-hmm.
So I'm going to use the formula over here to help me do this guy, okay? So I will write this as e to the power of ln a to the power x, okay? Everybody okay here? If you have question, please ask me now, okay? Because our question will become more and more difficult. Everybody is okay for here? For the exponential rule, you also have e, look, ln a to the power x. If you are on the exponential position, pull it in front. It is still equal. So far, so good? Correct? Olivia, let's see here. I want to do this guy's derivative. This guy is e to the power of this whole thing. Let's use the chain rule to finish. E to somebody's power derivative will equals to what? Olivia.
X ln a times e. Wait.
This you treat as a whole package.
Oh.
E to the power x derivative is itself. So you just copy down this first, right?
Oh.
Correct?
Yeah.
And then times the chain rule, okay? We do this whole package, copy down, times this guy derivative is who? Ln a is your coefficient, just like 5x derivative is 5, right?
Yeah.
So you times ln a. Does this make sense?
Yes.
And this guy is who? Is this right?
Yeah.
So you will say this is ln a times a to the power x. That is a formula for this guy. Okay?
Okay.
Yeah, I know this one is a little bit complicated. We will revisit this friend, okay? Yeah, we will revisit this friend. The reason most students feel confused here is because you feel confused here. You feel confused here, that's the reason. If any of you have any question, please ask me now. If you have any question for this box, ask me. I explain again. Nobody has question?
I have a question.
Let's go. Which
Uh,
one?
Could you just re-explain the a to the power of x?
A to the power of x, right?
Yeah.
Okay, let's see here. For example, if I say 2 to the power of x, okay? 2 to the power of x. This one. But I want to represent this function, use the base of e, okay? Because e is a scientific number. I'm going to change this. I want to change the e to the base. Then what I can do, if you want to change e to the base, then you have to make your exponents as a log e. And then you copy down this guy. You may feel curious that these two are not equal. I'm going to prove to you. E to the power of log e. And then here is 2 to the power of x. I didn't do any magic. These two overlaps always. Does this make sense a little bit now?
Yes.
What's the reason that this guy can magically equals this guy? It is just because this guy and this guy are the same. Let me see here one more time. Watch out, okay? Look, E is a base. E is a base. Let me replace this whole thing, okay? I call U equals to this. So 2 to the power x equals to e to the power of u. I want to prove this to equal, okay? Look, u equals this whole thing, right? Look, if this is an exponential format, this is an exponential equation. In your algebra 2, when you learn the log, if you have this equation, u should equals to log e, copy down here, this. Does everybody agree with me?
Yeah.
This guy is exponential format. Yes, this guy is exponential format. If you want to write down this in the log format, you put this on the base and you put over here. Log e 2 to the power x just equals to u. Just like what you do here. 2 to the power 3 is 2 to the power 3. So log 2 to the power 3 is 3. Does this make sense?
Yep.
Makes sense now? Olivia, how do you feel about here now?
Yeah, makes sense.
This is not easy, okay? This part is not easy, especially this thing. The reason is because the algebra 2 is a long time ago. And the last year, all the students pre-call online class, teachers skip so many things. So 90% students or 95% students already forget this. This is one of the important properties with log and exponential. this is true. So a to the power x, if I want to write down e as a base, I put e and I put ln. Ln is log e, and then I copy down this. You say, teacher, do I have to make e to be the base? You can use any number to change it. You can do 2 also, but then you do 2 here as a base. Listen, as long as this number are the same, that guy and that guy, always equal, always true. You can put here to be any number. It is always true. Okay, as long as a positive, because this guy has to be positive. Okay, that's about this formula. Okay, yeah, to do this one, it is not easy. Now let's move in, continue. Okay, yeah, let's see. I don't think the question here is hard enough. Anyway, let's try this one. Let's try this one. Emily, let's try this one. Go ahead.
You use the quotient rule, right?
Yes.
Okay, so sine of x
Something wrong with your microphone. Yeah, suddenly your microphone is not working. Not really. Okay, let me call other student do it first, okay? And I'll call you back. Olivia, let's do this one.
Okay, so it would be negative 2x and times sine x minus 1 minus x squared times cosine x.
I always put a parenthesis, okay? Yeah, because I don't want to mess up. Okay, very good. Continue, please.
And then over sine squared x.
Okay, one more step. Minus cosine x plus x squared times cosine x, right?
Yeah.
All right. Yeah, I believe this part is not hard. Now let's see. Let's do some ugly one, okay? We are going to use those kind of chain rule. Let's see here. Look at this. Angela, let's try this one.
Okay. Do you do tangent of x squared plus 7 times secant of x squared plus 7?
Who is the outlier?
The secant
Okay. Second derivative is who?
is tangent times secant.
Okay. We need to take care of the chain rule. Times
2x.
Because this guy derivative is 2x. And that guy copy down. Does this make sense?
Yeah.
Okay. Next, let's try a question over here. See this table, okay? See this table. So, Aiden, let's try this one.
Okay.
H prime x equals
It's f prime g of x then it's times the derivative of g of x.
derivative gx. And then we want to do h prime 2, right?
Yeah.
Equals f prime of g2.
Is -1.
G2 is -1. And the g prime 2. Okay, so this equals?
This equals, it's like -4/3 times 3, which is -4.
So f prime -1 is here. Times g prime of 2. G prime 2 is this, right?
Yeah.
Okay, makes sense now?
Yeah.
Okay, now, Olivia, let's try this one.
Okay.
And they give a ugly one. This is the ugly one. Product rule, okay?
Okay, so it's the derivative of f of x times g of f of x, and then plus f of x times the derivative of g of f of x, and then
Yeah.
times the derivative of f of x.
All right. Now we are going to do this guy at phi equals. Who is f phi?
1/4. Oh wait, f5, 2.
Plus f of phi times g prime of, who is f phi?
2.
2. Who is f prime at phi?
1/4.
Next, f prime of phi is who?
1/4. And then times -4 plus 2. And then times 6 times 1/4.
-1 plus 3 equals to 2. Correct?
Yes.
Now, Angela, let's do this guy derivative. Yeah, this answer is not for this, okay?
Yeah.
The answer is not for this. This is a circuit. So you're looking for which answer match to this after you do your calculation. Yeah. Let's do this one.
Okay.
We want to rewrite this first.
So it's tangent 3x squared to the power of -1/2.
Okay.
Okay. And then you can do -1/2 times tangent 3x squared to the power of negative 3/2. And
Negative
then
what?
negative 3/2. And then times is it secant squared of 3x?
Mm-hmm. Mm-hmm.
And then you times 6x?
Yes. All right. This is the chain rule. First layer, power rule. So you put this guy to here, and then you copy down this whole package. Doesn't matter how ugly inside. To the power of this guy, -1. Times, you get rid of this layer. You already take care. Let it go. You do this layer. Tangent derivative is secant square. Doesn't matter who is inside. You copy down. Now you take care of this layer. Let it go. You do this guy derivative. 3 times 2 times x to the power 1. There you go. Okay? If your teacher don't allow you to put a negative exponential, go ahead. Move it to the denominator. Any question are welcome. Please ask me if you feel confused. Let me know here, okay? Okay. Any questions so far? No question? Everybody are okay here? Emily, let's try this one.
Does my microphone work?
Yes.
Okay. So you take the derivative of the outside first?
Look, when this question, this guy really looks ugly. It makes you feel really confused. I will rewrite this, okay? Look, the guy on this corner is supposed to be on the shoulder, okay?
Yeah.
So when you do this, you want to rewrite this as the exponential format first, okay? And then go ahead.
2 sine of x squared to the power of just 1. Okay, no, just 2 sine x squared. Right?
Chain rule, yes. First, we always say the biggest rule is chain rule. You do chain rule first, and then inside the chain rule, the out layer is exponential, okay?
Mhm.
2 is a second order, so you put 2 in front, and then you copy the everything else. So far, so good.
Yeah.
Next, this
And
guy
then-
is gone, and you do this guy derivative. Who
So
is this?
cosine of x squared?
Very good. Now, you have already taken care of this one. This guy can be gone. You want to take care of this guy.
Okay. Yeah, so 2x.
Yes. Make sense?
Yeah.
Okay. You kind of feel confident for those chain rule now, right?
Sort of.
Okay. All right. When your teacher teaches this part, you are so much advanced than other people. Okay. Let's try this one also. Olivia, let's try this one. Go ahead, please.
Okay. So 7 times t cubed minus 2 to the 6th power,
Mm-hmm.
and then times 3t squared.
There you go. Then G prime 1 plug in. Go ahead, plug in.
Okay, so 7 times 1 minus 2 to the
Mhm.
6th, and then times 3.
There you go. This is how much?
7 times, wait, 21.
Yeah, very good. Even number, positive. There you go, 21. Okay. All right. Angela, let's do this one.
Okay. I think you can rewrite it so it's x squared plus 7 to the power 1/3 times cosine x.
Okay. Go ahead.
It becomes 1/3 times x squared plus 7 to the power of negative 2/3 times 2x and then times cosine x plus negative sine x times x squared plus 7 to the power of 1/3.
Okay. So students, this is like playing a game, okay? And you need to know the rules of the game so that you can do well. Out layer, this one, the biggest layer outside is using a product rule. So you will do the product rule. Product rule, you do this guy derivative times this guy copy down plus this guy copy down times this guy derivative. So when you do this guy derivative, you have to carry on the chain rule. Out layer 1/3 to the power of this guy times this guy to the power of this guy minus 1 negative 2/3. This guy derivative is 2x. Because it's product rule, you have to carry on this copy down. Because this guy derivative is negative, so you write down negative sine x times this guy copy down. When you do here, if you do chain rule for this, it's wrong. This part you already take care on this side. You don't want to take care of this again, okay? Because the product rule. So for any questions? Everybody okay here? Let me show you. Cosine, okay, look. If I do cosine x, if I want to do this guy, okay? I will write down this as cosine x squared. This is cosine x squared, is this guy. If I do cosine square x, in the calculator, they don't allow me to put 2 in the center. So I will do this format. I do a big parenthesis. I do cosine x, and then square. Students, these two are totally different, okay? Don't confuse with these two functions. They are totally different, and their derivative are totally different. Don't confuse. The order matters. Okay. Now, Emily, do this one.
You would rewrite it with the 2 on the outside, right?
Mhm.
And then you put so it's 2 times the tangent of 3x squared.
I put this first.
Oh, okay.
Okay. Now go ahead.
Yeah, so 2 times the tangent of 3x squared
Mhm.
times 6x.
Hold on. Hold on. You lost a layer.
Oh, I lost the tangent thing. Okay.
Mhm.
Yeah, okay, yeah. So secant square of 3x squared. Yeah, and then times 6x.
There you go. Does this make sense now?
Yeah.
Very good. Yeah, you catch things very fast. That's beautiful. Now let's do implicit method. Okay, now we are going to do implicit method. Let's see here. Angela, let's do the implicit for this guy, dy over dx.
Okay. It's 2x plus 2y times dy over dx equals 0.
Okay.
And then you can move the 2x to the other side.
Mhm.
So it'll become negative 2x.
Yes.
Dy over dx equals negative 2x over 2y.
Okay. We will do this. Okay. Make sense?
Yes.
Now we need to do the second order, second derivative. Aidan, let's try this one.
Okay.
How do you want to start? We will still do the same thing. Yes?
Yeah.
Okay, so we will do the same thing over here, but we will have something different. We don't write down this yet. We are going to do the derivative over here
Right.
on this. Go.
Okay, so I think it's like 2 plus I think it's like 2y times the
Look, hold on, okay. This, first we can get rid of 2. 2 and 2 cancel, okay?
oh, yeah.
We divide by 2, yeah, we can simplify it first.
Okay.
X derivative is 1.
Right.
Product rule, okay?
Yeah.
This guy derivative is
dy over dx.
copy down this. plus
It's y times d squared y over dx squared.
equals 0. Okay,
Yeah.
make sense? Students, this is a place almost all students feel confused. This two product is this. This guy is the derivative of the derivative. It's called the second derivative. This is the second derivative. Is the second derivative equals to this? Not at all. These have different physical meaning. Don't mess up them. This is y times. Okay. Does this make sense?
Yeah.
Dy over dx will equals this, correct?
Right.
Right. We will do here. Yeah, we can also do from here. Dy over dx 25. No, you see, this number doesn't matter. It's not going to affect the answer at all. So this guy will be plugging over here. So 1 plus negative square is positive. Make sense?
Yeah.
So y times d squared y over dx, which is, you should call this second derivative, okay? Equals -1 minus x squared over y squared. So far, so good?
Yep.
This is negative y squared plus x squared over y squared. Does this make sense?
Yes.
Common denominator. Who is this guy?
That's 25.
There you go. Okay. So second derivative equals negative 25 over y squared. Okay. They ask you at this point, so you plug in this guy to this.
Wait, is
That's
it 2y cubed?
Oh, you're right. Let's get one more step. Thank you for correcting. This is divided by y, so this is 25 over y cubed. This is y cubed is -64. So this equals to 25 over 64. Make sense?
Yeah.
Okay. That's what's going on for this question. Doing second derivative very often using implicit method. By doing derivative of this guy times this plus this guy times this guy derivative. Derivative of the derivative is the second derivative, but derivative times derivative is derivative squared. You can get the derivative from the previous step. You are going to plug in. Don't say this guy equals to this guy. They are not equal. Totally different meaning. Okay? All right. Is this difficult level okay for everyone, or you think this is too easy? Let me know, okay? All right, that's for today's class. I will upload the videos and I see you next week. If you have some hard question from your school, let your mom send to me. I will teach in next class, okay?